Hey there, Fashtus here. We're just going to have a quick look at behavior trees, the first steps for integrating one into the kit using Behavior Designer, and perhaps investigate a little bit at just how behavior trees work. So what we've currently got is our little guy over here. He is using standard AI, came with a kit, so he's wandering around and doing stuff. So he is a generic monster character entity. He's just straight out of the demo. Nothing added into him at the moment. You will see there's a few extra functions in the bottom of the monster character entity. This is due to the DevX extension that's added in. It just comes as part once the kit's once the add-on's installed. It's got a few things like he has the ability to remember attackers. He has the ability to send AI messages to the behavior tree. This is things like I've been hit, I'm dead. He has the ability to communicate between other monster character entities. These can be disabled just to avoid too many messages being sent around if nobody's really interested in receiving them. And it has a trial function here which basically takes some of the properties of the monster character entity, ally, ID, distance to tether to the start location, distance to attack, that sort of thing, and copies them into a bunch of local variables in the Behavior Designer tree list. There's some more information in the documentation on what those variables need to be called. Maybe better ways of doing this eventually, but at the moment just to avoid having to duplicate variables everywhere. Now, in order to start integrating a behavior designer into this guy, you have to initially remove this component, monster activity component. That is the base AI component from the kit. And the next thing we want to do is add a behavior tree. Now we can click on this open and that will create a behavior tree for us, but what I've found is that tethers the behavior tree too closely to a single game object. You can't duplicate it, you can't do much. So what I've tended to do is we go to a sample folder somewhere, create Behavior Designer external behavior tree, and we'll just call it test. And this external behavior tree can be duplicated and copied and moved around and added to your source control and added to a variety of behavior trees on any sort of game object. So we've now linked that tree to this behavior tree to this monster entity, and so this tree will now run. Now by default this is a run once every frame. I'm not going to add a behavior designer manager to the scene, which you can do if you like, but any tree that is discovered in the scene will add a manager if it doesn't exist. The only reason you might want to change the manager is by default the manager iterates through each tree once per frame. It's quite CPU intensive. If you want to avoid that, maybe if you don't have an FPS and you're not too worried about how often these things need to be checked, you can add a manager to the tree, to the scene, and then just change it to say once every 1 second or once every 1.1 seconds. Now the other thing you would probably need to do is this restart when complete. Enable that. Behavior Designer will run any behavior once and that's it. It's a bit confusing. There are situations where that could be useful, but in this we would like to run quite often to make different decisions based on what's happening around us, and so by setting restart when complete, that means this tree runs over and over and over again. Reset values on restart, something we probably don't want to do because we often use variables, local variables in these trees to contain some information. The rest of it you can find in the documentation. Now we're going to want to look at our tree in this editor. You can load the editor through Tools, Behavior Designer Editor, and I'll just maximize this. Editor is basically empty. In the editor, the task that we've added with the add-on can be found under MMORPG Kit. There's our actions, and further down with conditionals there is a similar subsection with a similar bunch of tasks. Generally, the first thing we're going to want to do in a kit behavior tree is add a sequence. Sequence runs every action below it, one after another. The moment any one of them fails, the whole sequence fails, and if all of them return a success, the sequence returns a success. Now, for our kit, what we really are interested in initially is checking to see whether the behavior tree is being run on the server or not. We don't tend to want these behavior trees to run on the clients. It means that the clients can control AI behavior We don't want that to happen. We want the server to control the behavior, the server to tell the monster entity to do stuff, and then the kit to then pass that information down through the netlib, or libnet, or whatever it's called. So this will be our first action. Very simple, doesn't have any properties or anything. It basically returns a success if we're on a server, if the script has been run on a server, and a failure if it is not. And because this is a sequence, if it is not on a server and returns a failure, the entire sequence aborts out, returns a failure to the entry point, and nothing else runs. The second item we're interested in looking at is entity active? And now the entities have a subscription system where if a player or any sort of player gets close enough to them, they subscribe to that player, or the player subscribes to the entity, and the entity can interact with the player. Basically, if we're far enough, or if there are no players near a monster entity, obviously we don't really want that entity to do anything, and so that's what this action or conditional will do. If there are no subscribed players, that means the entity is too far away from anyone to make a difference, and so we kind of don't want to do the rest of the tree. We don't want to waste CPU time getting it to look for players when there's no chance that there can be a player. We don't want them to answer any responses or anything. You can play around with this a bit. There might be some stuff that you wanted to do. You possibly might want them still to wander around randomly. Maybe respond to distress calls from other players, so that the player's attacking somebody, and then off from scene camera left, a bunch of other AI come running along to help them out. But by general, this is your standard sequence. Are we on the server? No, we're not. Okay, we do nothing. Are we active? No, we're not. We do nothing. Now, I generally start the whole AI system under that. Now you notice we're going top to bottom, left to right. So this selector runs all of the actions below it, and it returns a success as soon as any single one returns a success. So this is ideal for a bunch of options. I'll do this, or I'll do this, or I'll do this, or I'll do something else. And as soon as one of them works, it doesn't bother with all the rest of them. So we can have a look. Let's have a look at one of our sequences. So this is our most unimportant sequence, and we will say that is patrolling. So this is all the way at the far right, the last thing. Everything else is more important to this, but if nothing else happens, we can do some patrolling. So nothing else is of any importance, and we've got a wander randomly action, and we will add in after that a wait. And the wait time 1. I mean, we can muck around and say we want a random wait between values, but wait time is 1. So if we look at this tree, we check out if we're on the server, if we're active, and then because nothing else, we just go straight into patrolling, and we wander around randomly. The wander randomly has a few options. Maybe you want to sprint, maybe you want to wander randomly with a radius of 50. This location point is the pivot point around which we wander. Now at the moment we don't really have any location. In some of the other scripts you can see basically when we start out, I might show you in this one, we immediately grab the very first time the script runs, which is our origin point, and we remember it, and so we could wander around this. Now if you know, Behavior Designer has a little button here. This button allows us to toggle between hard-coded value and a selection of variables. We don't have any variables yet, but we'll stick with this in the moment. Object to move. Now there's a few scripts that do this. It may or may not be useful. I can choose an object to move. This is a game object. Or if it's not set, it is the current game object that this behavior tree is set to. Layer name, we might actually be removing this. This was essentially allowing us to target the terrain to ensure that we're actually sitting on terrain, but so far I've made some change that we don't need that, so I might remove that. Anyway, this is our patrolling script. So something else we might want to do, tasks. Let's have a look at another sequence. And this is more important than the patrolling, and we will call that sequence do we see an enemy? and we'll introduce a few things here. So see an enemy, there is a task. I'm not quite sure what we call it, just go and double check our conditional. Can we? Yes, there we go. Called can we target player? Possibly called also can we see player. It's got a variety of functions. See, here, first, closest, furthest, random. It must be within a range. The range must be within a certain distance. The sight cone. And then finally, the output is in player detected. So if any of this works, and it can see the first player within range, within that sight cone in front of them, it populates this variable. Now we will have to create that variable first. Let's call it targeted player, and there will be in here a player entity, which is a variable added in by the Addon code. And if we go back to the inspector for targeted player, we've now got targeted player of that type. So this is more important than patrolling. Do we see? It has to be the first character we see, and they must be within range, they must be within 60 units, they must be within a sight code of 45 degrees in front of us, or maybe we're just interested in hearing them. Hearing doesn't have the sight cone, it could be in a radius around them, but let's see. And if all of this succeeds, it returns a success, and it populates this targeted player variable. Now I'll introduce something new here. This sequence is important. Now this patrolling has a wait time. Now if we make the wait time say 10 seconds, so we wander randomly from one point to another within a radius around that central pivot location, and then once we've gotten to that location we will wait for 10 seconds. Now if the enemy walks past them during those 10 seconds, nothing happens because we're still processing this event. So something that behavior trees have is what's called an abort type. An abort type is options between self, lower priority, and both. Now lower priority is what we're going to use here, and what that means is this conditional, which this is a conditional, this can we target player, will be checked constantly, and if the results of this change, it will interrupt any task or action below it. Any task and action below it will be interrupted. This task will be rerun, this conditional will be rechecked, and everything changes based on that. So even though we're waiting, because we've got an abort type of lower priority, if suddenly a player moves within this sight cone and this now suddenly returns a success, not a failure, we abort this wait time, we'll abort this everything below us. Nothing above us, but we will abort everything below us. The other option is self, and that only works within items below this or underneath the tree, not to the right, but underneath it. So if there was a variety of tasks underneath this one, and the first one was a conditional, and the second and third and fourth were a whole lot of stuff. So if I had, say, if we had a wait here, and this wait was running, but suddenly a player moved within range, it would abort this wait, re-evaluate this conditional, and exit out as possible. But it would not abort this wait because we're only interested in the ones below us. If we have set to both, it will abort everything. If any conditional in this sequence changes, the answer changes, it will abort any other action, anything to the right of it and anything to the below of it. So that's basically, they're a bit sort of complicated, but it's quite useful, and that's what we would want to do. So while you're patrolling, he patrols, wanders randomly, waits for 10 seconds. If during that time he sees an enemy, It aborts that wait and then populates the targeted player with the enemy. Now we'll have another sequence further up, and well, give an example of being attacked. Now, being attacked relies on the BT AI events that you can enable in the character. So we actually rely in this case on Behavior Designer events. So, and if the player hits a monster character entity, the monster character entity detects that it is being hit and it sends off an event to the Behavior Designer saying, I've been hit. Now, Behavior Designer unfortunately is limited to these events, and it may be worthwhile me writing codes that handle enum events, but it sends them via strings. And so the monster received damage. This is all in the documentation, but that is the event that gets sent to this behavior tree if they get attacked. And it receives one variable, the first stored value, and that is what player attacked. So this is the two different ways now that our variable targeted player can be filled. One is if it gets seen in this action, and the other is if it gets received here. So we'll have to change that because that's not, double check the documentation on this. This is actually a unsigned integer. Target player ID. That's actually an unsigned integer, and the reason for that is it allows us, that's the actual game object ID of the player that attacked. So documentation defines that. That is actually the targeted player ID, and the reason for that is we have a second task called Am I Being Attacked? So once the event is received, Am I Being Attacked takes the targeted player ID and then process it through a bunch of checks. Is the player dead? Is the player still in the current scene? Is the player a variety of things? And if that is true, it populates the targeted player object, targeted player entity. Received events, unfortunately, the way that Behavior Designer works is it sends all values as objects. Just plain objects, no matter what they are, they have to be sent back and forth as objects. So you can never be quite sure what variable type you're getting in this property. That's why the documentation covers basically that. So this would be our being attacked. We get an event, we get the ID of the player passed to us that actually applied damage to this monster character entity. We double check with that. If the ID player still exists in the scene, so they haven't hit us and then run away, they haven't hit us and then been killed by somebody else, variety of other checks. If that is all true, our targeted player is set, we return a success. Similar to see an enemy, we kind of want that to have an abort type. So we could be patrolling, wandering around, sitting there waiting for our 10-second, and somebody hits us on the head. This instantly breaks out because this received event is a conditional. This is now returning different information. It didn't have an event previously, now it does, and so this processes and being attacked. And we'll go and add a very basic attack. So our sequence goes over here. We'll just call that attack. And there is an attack target task. Inspector, target player. It's badly named. To remove that. This is similar. This is who's being attacked by, but target player is that. Definitely have to fiddle around a bit with these. But that's basically a targeted player, and we have a timeout, which I think is to do with the duration after the attempts which return a timeout and return a failure. Yes, that's right. So this timeout, if we cannot attack the player after a few seconds, it times out and aborts this process. This is because the player could be kiting the character. They could be in an area where the monster can't get to, and a variety of other sort of points. This possibly could do with a check. So there is a check variable. Set player targets. Set player targets. That we probably don't want to actually was the conditional that we want. Doing the wrong one. That was the action. We do want the conditional. Has target, and this returns a success if it has a target and a failure if it doesn't. So if we don't have a target, we don't try and attack anything. We skip on to the next. We check, we haven't received an event, we skip on to the next. We check, do we see an enemy? That also returns a false. We check onto the patrol, and then we start patrolling. And that's essentially how a very basic attack tree would work. Still, as I said, a few bugs. Attack target probably has a few things in it which are legacy. And in fact, I think some of these are probably private variables that shouldn't be private. Has target. You could do a little bit more in here. Check to see if the target's dead or not. Has target basically just determines that the target's there. You can also perhaps put a weight in here. So hit the person, wait for a few seconds, hit the person again. That's an option. Certainly for attack, you'd probably want to do similar with the abort types. So the moment has target changes, being a conditional. So the moment we get a target, it aborts everything else and runs this. It may or may not necessarily be necessary, simply because once you're given the targets in these two, it immediately ends the tree anyway. But it certainly will speed things up for determining when it starts attacking. There's a few other actions that you can do to do special attacks. You can do some randoms. Now, to be aware of, there are some random probabilities, conditionals, and random selectors and sequences. So you could easily put a random selector in here. So this will run any one of them, and then do special attacks in here. Have a couple of special attacks actions. So it will randomly select one of those and do them. There's also, if you look at the composites, there is utility selectors, which could possibly be used for boss monsters, and that handles, you can put a variety of things underneath that, and they query a utility function in your underlying actions. And the utility being, the higher the utility, the more likely the function will be fired off. So attack might be very high, but over time, as damage gets taken, the utility of the heal spell could be higher, and then they'll heal themselves. So it's a variety. This gets very complicated. So this is a basic tree. I don't know that there's much else I can talk about with this. I've definitely come up with some bugs, which I will fix. So I'll fix those up and enjoy. We'll talk later.